Hi, welcome to my YouTube channel. In this video, I will be talking about one sample t-test. This involves comparing a population mean to a specific value where sigma is unknown. We will be looking at the following example. The data provided shows the number of years 20 fresh graduates spent on their first job. Tester recruiters claim that the mean number of years fresh graduates spend on their first job is greater than 5 years. Take the level of significance to be 5%. The data is shown here. To be able to do this test, our claim is that the population mean is greater than 5. So as a result of that, our claim is the alternative hypothesis. Then the corresponding null hypothesis will be the mean is less than or equal to 5. We're going to be performing a one-tailed test that is right-tailed. To be able to do this, I will take my data into SPSS. Once the data is in SPSS, we would go to Analyze, Compare Means, One Sample T-Test. We move years into the test variable box, change the test value here to 5, and then for the options we have 95% because our alpha level of significance is 5%. We'll click continue and then OK. The output is provided for us in the output box. In the output box, we have the information containing the summary statistics in the first box, and in the second box, information about the one sample t-test. We're now going to use this information to solve the problem. Based on the information from our table, we can pick out the p-value. Notice the p-value is for a two-tailed test, but our test is one-tailed. So to get the p-value for our own one-tailed test, we have to divide this value by 2. We divide 0.506 by 2. We get a p-value of 0.253. We can compare this to our alpha, which is 0.05. Since the p-value is greater than alpha, we fail to reject the null hypothesis. In this table, we can also obtain our test statistic, which is 0.677. We are now going to proceed to show how to manually calculate this value. To be able to use the formula, we need the summary statistics. This is the same summary statistics we got from our SPSS output. We have the mean and the standard deviation. So we use the formula t equals to x bar minus mu over s over square root of n. X bar is 5.5. Mu is the hypothesized mean, which is that we are comparing our population mean to, which is 5. Our sample standard deviation from the table here is 3.3, and our sample size is 20. We compute this, and this gives the same test statistic we got from the previous table. Next, we need to find the critical value. To be able to find the critical value, we can find this from the t-distribution table, or we can use Excel. The degrees of freedom is n-1, which in this case is 19. The area on the right tail, since it's a right tail test, is 0.05. So if we put in t.inv 0.05 19 into any cell in Excel, it returns a critical value of negative 1.729. But since this is a right tail test, it's the same area on the right tail, I will be picking the positive value because it's a right tail test. Next, we compare the test statistic to the critical value. We see our test statistic is less than the critical value of 1.729. So as a result of that, we fail to reject the null hypothesis. Next, we can compute our p-value manually. We go to Excel and type in t.dis.rt since it's a right tail test. Then we put in the test statistic, which is 0.677, and the degrees of freedom of 19. It returns the value of 0.253, which is the same value we got earlier on. Again, if we compare this to alpha, we still fail to reject the null hypothesis. So we can see from the results that we got that the rejection region is on the right tail. Alpha is 0.05. The critical value associated to that is 1.729. The test statistic is outside of the rejection region. So as a result of that, we fail to reject the null hypothesis. Hence, we can conclude that at 5% level of significance, we do not have sufficient evidence to support the recruiter's claim. Thank you for watching this video. I will see you in the next video.